Good morning, everyone. I want to go over a few things with you today concerning solar activity. If you remember in class, I mentioned that every now and then the sun burps. Well, not exactly burping as you and I think of it, but every now and then the sun does belch out some material, either in the form of particles or electromagnetic radiation, i.e., light. So we want to talk about just some of the factors that are involved in this solar activity. We're going to start with sunspots, and sunspots are dark blotches on the sun, and they're much cooler than the surrounding areas of the sun. Don't get me wrong, they're still very hot, but they are cooler in temperature than the surrounding areas. We'll talk why that is in just a second. But sunspots can be huge, maybe up to 50,000 miles or more in diameter, and they contract and they expand. Now, sunspots and solar activity in general, it's kind of odd, but it runs on an 11-year cycle, and astronomers do not know why. But this 11-year cycle consistently moves to a high and low sunspot activity. Right now in 2020, we're at a solar minimum. So you can take a look at this graph, and you can see back in 2014 and 2015, we were at a solar maximum. And so this curve, we drop down and we see less and less and less solar activity. So here in 2020, 2021, we are at a very, very small minimum. There has not been many sunspots the last several years. And as we move up here, we predict that astronomers predict that in 2025, 2026, we will be back at a solar maximum. And that's an approximate 11-year cycle. And again, astronomers don't know why that solar cycle is 11 years, but it is. And sunspots, originally with Galileo, allowed people to estimate how fast the sun was rotating. As it turns out, the sun rotates about once every 25 Earth days. So, and the sun's really big, and it's a great big ball of gas. So, different regions of the sun obviously rotate or spin at different rates because it's gas. You're going to have a lot more rotational velocity at the equator than you would at north and south latitudes. Now, the sun has crazy magnetism going on. Whenever you have all this plasma moving up, all these charged particles, they generate a magnetic field around them. So what we have is almost like a huge bar magnet underneath the surface of the sun in multiple regions. And when the charged particles, when they leave the sun, they often will loop and go back to a nearby sunspot, like a north to south pole, because they're charged particles and they're following the magnetic field. And you have something like this. This is known as a prominence. Here's just a really quick look back in 2014 at the solar maximum. There were some huge sunspots, and here's the Earth compared to some of these sunspots. Some of them are as big as Jupiter or bigger. Sunspots are about 10,000 degrees Fahrenheit, and remember, they're caused by an upwelling of the sun's magnetic field. They can last for weeks or months, and as you just saw, they can be wide or wider than the Earth or other planets. Sunspots, when they occur, they can signal upcoming solar flares. Solar flares, as you know, can reach the Earth, interfere with satellite communication, and cause the Earth's atmosphere to expand as it's heated. Well, this is a problem because when the Earth atmosphere expands, then satellites continually run into it more and more often as it's getting more and more wide, and that causes orbital drag. And as you know, if the satellite is out here and experiences drag, it's going to begin to slow down and get closer and closer to the Earth. And that's a bad situation to be in if you're trying not to smash back into the Earth due to too much gravity. The Van Allen belts protect the Earth from coronal mass ejections and solar flares to a degree. The Van Allen belts are the magnetic fields of the Earth, and they deflect a lot of the incoming solar radiation. If we did not have the Van Allen belts, we'd be in trouble. And remember, the Van Allen belts